name is Scilzo. I'm an adjunct professor at Jackson College, and today I would like to show you how to find a factor of safety. Now, I'm going to go over a bunch of previous definitions that we've used and then introduce one more from the three previous videos I've done. And just as a quick reminder, I'd like to redefine what these things mean. First one is stress. Symbol sigma is equal to the force over the area. Okay, in an axial stress situation, again, is force over area. Strain is defined by epsilon, and that is equal to delta over L0. Now, briefly in the last video, I just mentioned that Young's modulus up to the proportional limit. Young's modulus capital E is equal to stress over strain. Okay, and you can use to manipulate, and I'll expect you in my class to be able to manipulate these different equations to find a factor of safety or be able to find a number of different things based on these different equations. The yield strength leader, you normally can get this from a book. In other words, if I were going to find a certain steel, we're talking about metallurgy in our course, and so as I find a certain steel, you would find the yield strength in a book, depending on what you would typically use, because they've been tested, and they would say, okay, our yield strength is going to be in this range. So either I would have to give you that if I were to give you a test, or I would tell you exactly where to look for it. But that is something you would not be able to calculate, you would be given that. Now, the new concept that I'd like to introduce is something called factor of safety. This is used in automotive, it's used in the aircraft industry, and it's basically to say how safe do we want to be. The higher the factor safety n, the safer we are. Now you say, well, why don't we make it 5 or 10 or whatever? The thing is that it involves cost. You would have to have that much additional material or use a more expensive material that you might not need to use. You use a reasonable factor of safety to determine what material I need to make this out of and how big it needs to be. And the bigger you make it, the stress obviously goes down, or the stronger you make it, and the yield strength goes up. So you have those choices. So my factor of safety is simply my yield strength divided by stress. You've got the equation for stress here. As I told you, you would pull this somewhere from a book or it would be given to you, and you could then figure out your factor of safety. Now, if the factor of safety is less than 1, it is unsafe. This means you will go into plastic or permanent deformation. At that point, you can no longer use that material safely, unless there are certain circumstances that we won't cover in this course, where you would want this to be in permanent deformation. But in general, you would want your factor of safety to make sure that it is 1 or greater. Normally, in the course, I've been using anywhere from 1.3 to 1.5 as a factor of safety. I've worked in the automotive industry for 20 plus years, and that was generally where we were at. In the aircraft industry, I've heard that they use sometimes 2 and sometimes even higher factors of safety. But what I want you to understand is, in the course, you can then use these different equations to manipulate. You can use these to find L sub 0, delta. You can eat from these different equations as long as you're in the proportional limit, below the proportional limit. And as I said in the previous video, we assume that the yield strength is almost linear. It's not quite linear, so a lot of times you'll see that we'll use that all the way up to the yield strength. Hopefully that this has been clear. Again, how factor of safety works. Again, yield strength over your stress. Thank you very much for your time.